Hello there and welcome to this course. The goal of this course is to help you incorporate the Eclipse MicroProfile for Tolerance API into your enterprise Java applications. We're going to start by briefly looking at what the Eclipse MicroProfile project is, and then we're going to dive deep into the various fault tolerance annotations that you can use to create powerful, resilient, and scalable Java EE applications. So let's get started. Okay, so what is Eclipse MicroProfile? Eclipse MicroProfile is a community-driven initiative that is a collection of abstract specs that form a complete solution to help you as an enterprise Java developer to write modern, powerful, cloud-native applications. MicroProfile is built on top of Java EE, and so it borrows a lot of the Java EE programming paradigm. The Payara server platform implements the Eclipse MicroProfile specifications. So to run the Eclipse MicroProfile specifications or the Eclipse MicroProfile project, you would need an implementation, and the Payara server is a perfect implementation for that. The goal of this course is to help you to incorporate the fault tolerance API of the Eclipse MicroProfile project into your application. Let's take a look at the APIs or the annotations we're going to be taking a look at in this course. Okay, so what is the fault tolerance API of the Eclipse MicroProfile project? Now, to understand what the fault tolerance API is, let's understand the problems it aims at helping you solve. Let's say you develop an application and overnight it becomes a success. It hits the front page of Hacker News or Reddit or any such popular site. And then suddenly you have a flood of requests to your application. Now, if you don't have any preparation in place, you would end up having your application crash. The fault tolerance API is designed to help you manage such situations so that you can have cases where if there is a lot of requests flooding into your application, you can actually queue those requests. You can minimize the impact of a sudden spike of traffic on your application. So the fault tolerance API is designed to help you minimize downtimes in your application. To get started with it, you need to add the dependency of the Eclipse MicroProfile to your project. Now, the sample code for this course and a companion guide are both available for download from the Payara website. Now, let's go into the IDE and start looking at the fault tolerance API.
Okay, so in our IDE, this is the project object model file. We have a dependency on the MicroProfile project. The current version as at the time of this recording is version 3.2. So we've added that. That's the only dependency we have in our project. And we also have the Payara Micro to deploy our application on. So this is the only dependency that we have. Now let's come in here and look at the root of our application. We have JAX REST endpoint, fault tolerance REST, located or hosted on the path FT, and we have a single method here, resource method called getCurrencyInfo, hosted at the path currency /, then you pass in a country. This is a path parameter called country. We grab it in here, and then we use this particular dependency that the fault tolerance REST has on the controller class here, and then we use that to get the currency info. We pass in the country. Now this particular invocation returns a currency info, which is a simple POJO that has the code, the name, and then the symbol of the currency of the given country. Now the fault tolerance REST has a dependency on the controller class here, and this controller class here is where a lot of the magic takes place, and the controller class here also has a dependency on the data fetcher class here. This is where we actually go out to the rest countries.eu resource that has information about every country on earth, from currency to flag to history and all of that. It's available on that particular REST endpoint. So we are using the JAX-RS client to make that particular invocation. Now we are going to spend a chunk of our time in the controller class. So which fault tolerance annotations are we going to look at? The first of the fault tolerance annotations we're going to look at is the fallback handler. Now, the fallback annotation is essentially used to tell the MicroProfile runtime to fall back to a designated method when an exception is thrown from the annotated method. Now, the fallback annotation here is an interceptor binding. So when there's an exception thrown from this particular getCurrencyInfo class, for instance, we are telling the MicroProfile runtime to actually fall back to this particular method here, defaultCurrencyInfo. And defaultCurrencyInfo is defined in this same class controller. Now, the fallback annotation can be used this way or in another way by defining a fallback handler. And a fallback handler is simply an interface that you implement and then can pass that into the fallback annotation. Let's take a look at it here. On the fetchCurrencyInfo class here, we are annotating it with the @fallback annotation, but instead of passing in the fallback method name as a string, we are actually passing in a class here, currency info fallback handler.class. Now this class here is implemented as a fallback handler that takes, it's a parameterized interface that takes a currency info with just one method, handle. So this particular @fallback annotation here is passed the fallback handler implementation, and then when there is an exception thrown from this particular method invocation, then whatever is declared in here is going to kick in. So that is just about it with the @fallback annotation. You use that to declare an alternative method that should be invoked in case there is an exception thrown from the annotated method. And the fallback annotation can either take a value, a string value for the fallback parameter, or it can take a class that implements the fallback interface. It's your choice. Whichever you choose to use works the same. The only requirement is that if you go this particular path here, if you use the fallback method and you pass in a value, which is the name of a method, this particular method here should be declared in the same class of this particular annotated method. So in this case, if this method was defined in a different class, our application wouldn't compile, would have a fault tolerance exception at startup. So that is just about it with the @fallback annotation. Use it to declare an alternative method that should be invoked if there is an exception thrown from the annotated method with the @fallback annotation. The next annotation from the fault tolerance family is the @timeout annotation. Now this @timeout annotation is also an interceptor binding that can be used on a class. We could have annotated this class with @timeout, for instance, like this. And then we could specify a value for it. So you can use the @timeout annotation on a class or on a method. Now what the @timeout annotation does is that it times out a method invocation after the declared class. So in our usage here, let me just remove this. In our usage on the getCurrencyInfo class here, we have set the value to 5 and we are setting the unit of time to seconds. So chrono unit does seconds, you can set to milliseconds, you can set to hours, years, really. It depends on you. But here we've set it to seconds. So we are saying that this method invocation should time out after 5 seconds. That is what we are saying. So those are timeout annotation used on this method means that an invocation to this method will time out after 5 seconds. Now, if we had used this particular annotation on the class like this, it would mean that all methods in this class will time out after this particular time unit that we've declared here. Now, you can use the at timeout annotation with the other at fallback for tolerance annotations, like with the at fallback annotation here. So what is happening here, let me undo this, is that with the at timeout annotation, after 5 seconds, if this method has not returned, it will be timed out, and then this fallback method will kick in. So that is just about it with the at timeout annotation. Use that to set a timeout for method invocation. In a cloud native environment, you don't want one method eating up a lot of CPU cycles or memory, spending a lot of time executing. You want to set a timeout on your method invocation. So once that timeout is reached, it should automatically be cut off, and then you can declare a fallback method that the MicroProfile runtime should invoke on your behalf as a fallback. This is very powerful because then it helps you to cut down cost in a cloud environment where you are billed by the seconds or even sometimes by CPU cycles. So you can use the at timeout annotation in here. Let's just look at the declaration. You can see the default value is 1000 and the default unit of time is milliseconds. So we could have just declared this like this. We could just say 500 like this, and then this would mean that this method should time out after 500 milliseconds. So that is how we use the at timeout annotation in addition to the fallback, for instance, to declare a fallback when we time out a given method. Use this to save cost in your cloud environment. The next fault tolerance annotation is the at retry annotation. Now, similar to the at timeout annotation, the at retry annotation can be used on a method, as we've done here, or on a class. When used on a class, it means all the methods in the class will be retried as per the parameters passed to the at retry annotation. When used on a method, then only that method. Now, when you use it on a class and a method, the at retry annotation on the method in the class takes precedence over the class level at retry annotation. So what does the at retry annotation do? It's used to retry requests to a given method. Now, in a microservices environment where you have a lot of microservices interacting with each other, it's inevitable that you will have sometimes some requests not going through. Now, it's going to be really tedious to just give up once a request fails. What you want to do is to have a resilient system that can retry requests to a given method. Now, that is what the at retry annotation does. We've used it here with a number of parameters, so let's quickly run through them. We are saying at retry on runtime exception.class. So we are saying if this method throws a runtime exception, then retry the invocation. Now we have a delay of 400 milliseconds here, and we have a maximum duration of 3200. Now what we are saying is that for every retry, set a delay of 400 milliseconds. And the max duration is the maximum duration of time we want to retry this particular invocation. Now the jitter here is used to set the effective delay. Now we set the delay here to 400. Now we want to give our retry some kind of randomness. So we use the jitter to set the effective delay, where the effective delay becomes the delay plus the jitter, and at another time you have the delay minus the jitter. So the effective delay becomes 250 to 550 milliseconds. Either of them, any of them, between that range, we can have the retry taking place. And then the maximum retry is 10. It doesn't really make sense to keep retrying infinitely. So once this particular retry is exhausted, as we have annotated this method with the @fallback annotation, it will hand over, or it will fall back to this particular class here, and then when it falls back, this particular handle method will be invoked, and then this particular default currency info will be returned. Let's look at the declaration here. As you can see, it's an interceptor binding, and it has a number of parameters. Some we've not really used. There's a number of them. Let's just briefly look at them here. You can see them here: max retries, delay unit, max duration. Now the delay unit here, the default is milliseconds. So in here, everything here is in milliseconds. So that is just about it with the retry annotation. Use that to create a resilient system that can retry requests without simply giving up at the first sign of a problem. It takes a number of parameters, research, and then pick the combination of parameters that suit your given situation. The next annotation is the CircuitBreaker annotation. Now the @CircuitBreaker again can be used on a class or on a method, and it can be used on a class and a method in the same class. Now when used on a class and a method, the CircuitBreaker annotation on the method takes precedence over that of the annotation on the class. When used on a class, it also means that all the methods in the class will be affected by the works of the CircuitBreaker. So what does the CircuitBreaker do? Now remember our initial example of our application hitting the front page of Hacker News? We might have a flood of requests to our application, and if we don't have a CircuitBreaker in place to check things, we might find our server crawling. So the CircuitBreaker is used to control sudden spikes, especially in a request environment or in an application. So what we have here is a declaration of the CircuitBreaker on the fetch currency info. We've passed in a number of parameters. The first one here is the success threshold. Now let me leave this. The request volume threshold and failure ratio here work hand in hand. Now at any given time, a CircuitBreaker can be in the open, in the half open, or in a closed state. Now mostly when the CircuitBreaker is in the closed state, it means requests can go through. Now the CircuitBreaker will trip to the open state when the failure ratio here of 0.75 or 4 requests fail. So the request volume threshold here is 4, and we are saying that the failure ratio is 0.75. We are saying that if 75% of the request threshold here fails, then the circuit should trip to the open state. When the circuit trips to the open state, we are saying it should have a delay of 1000 milliseconds before tripping to the half open state. Now in the half open state, we are saying that when 10 successive requests, as we have here the success threshold, when 10 successive requests are able to go through the request stream, then the circuit should transition to the closed state. So that is it about the parameters of the CircuitBreaker here. Let's just briefly take a look at the declaration here. You can see here. You can see we have the fail on, delay unit, request threshold, failure ratio, success threshold. So in our case here, we've not used all the available parameters, but they are there for your per user. So we have a CircuitBreaker here that has a failure ratio of 75 with a request threshold of 4, and at any given time the circuit can be in an open, a half open, or a closed state. Now, if the circuit is in a closed state and then 75% of this number of requests fail, which is 3, then the circuit should transition to the open state. And then in the open state, delay for this number of milliseconds and then transition to the half open state. When you transition to the half open state and then 10 successive requests go through, transition to the closed state. So that is how you can use the circuit breaker to design powerful, resilient, cloud-native applications. Okay, next up, let's look at the asynchronous annotation. Now, this annotation is used to declare a method to run asynchronously. Now, let's quickly take a look at the declaration. You can see the target here is method and type, which means that this particular annotation can be placed on a class or a method. When placed on a class, it means all the methods in that particular class are going to be invoked asynchronously. You can see that it takes no parameter whatsoever. Now, the asynchronous annotation here means that whatever method is invoked is going to be run on a separate thread from the thread that invoked that method. And there are two requirements. The only requirement for using the asynchronous annotation is that the method annotated asynchronous returns a completion stage object or a future. Now, the spec recommends the use of completion stage, and that is what we are using here. So we are returning a completion stage object of a list of strings. Now, this geofetch method here simply returns a list of country names. It can be a huge list and it can be time consuming because we make a request to an external resource. So this is something that you want to run on a separate thread from the thread that invoked the method. So back to the annotation here, the get country list here will be run on a separate thread. And then once it's done, it returns a completion stage. And our list here will be wrapped in that completion stage. Now, this particular annotation here is used in conjunction with the @fallback annotation. So we are saying that if this particular invocation completes exceptionally, then fallback. Now, the fallback method here is the fallback country list. Now, when you use the @fallback annotation and you go this particular path, passing in the fallback method, the signatures of the fallback method and then the method that you are declaring a fallback for should be the same. So in this case, the fallback country list and then the get country list all have the same signature in that they return a list of strings wrapped in a completion stage object. So using the asynchronous annotation on the get country list method here, we are returning a completion stage object that wraps a list of strings. And if this particular request completes exceptionally, we are saying that the fallback or the runtime should fall back on this fallback country list that returns an empty list of string wrapped in the completable completion stage object. So that is how you can use the asynchronous annotation to create very, very responsive applications, so that when you have a time-consuming task, as we have here, this particular request here could take some time because we go all the way out there, get a list of countries, and then we selectively pick only the names from the response that we get. This can take some time. So for such a situation, you want to run things on a separate thread so that your application will remain responsive. Once your application is responsive, your users are going to be very happy. So we do that. We achieve that using the asynchronous annotation. And you can see that the various fault tolerance annotations work hand in hand with each other. So we are using the asynchronous annotation at timeout, at fallback here. So if this particular request completes exceptionally, then fall back on this particular method. So use the asynchronous annotation to annotate your methods that are long running, that are time consuming, to get them to run on a separate thread, and then wrap your request in a completion stage object and return it. You can also use the fallback annotation to declare a fallback method if things complete exceptionally. A cool addition from the Payara server platform to the use of the asynchronous annotation is that you can declare another annotation that you want to have the same effect as the Eclipse MicroProfile asynchronous annotation. So let's come to this particular file here. In the MicroProfile, Eclipse MicroProfile config properties here, we need to set this particular key here, the MP fault tolerance alternative asynchronous annotation. Now in this case, we want the asynchronous annotation from the EJB API to have the same effect as the asynchronous annotation from the Eclipse MicroProfile project. And the Payara server platform allows you to achieve that through the setting of this particular value in any of the config sources. Config API is part of the Eclipse MicroProfile project, and there is a complete guide from the Payara platform for your use if you are interested in the config API. So you can use the EJB annotation as we have seen here to have the same effect as the asynchronous annotation by setting this particular key. The final annotation we're going to look at is the Bulkhead annotation. Now this annotation can be placed on a class or a method. When placed on a class or methods in the class, we'll have the bulkhead applied to them. When placed on a method and a class, then that of the method takes precedence. Now the bulkhead annotation is aimed at helping you minimize the number of concurrent requests that hit a given component. Now, if you have a component that has the potential to be hit by a large number of requests, you can use the bulkhead to control that. There are two ways of realizing the bulkhead pattern in the MicroProfile runtime. The first one is the thread pool isolation, and the second one is the semaphore isolation. Now, you can use the thread pool isolation method if the method that you are annotating as with the bulkhead annotation is an asynchronous annotation. In effect, to use the thread pool isolation method to realize the bulkhead, you have to use the bulkhead annotation in addition with the asynchronous annotation. So in this case, this method is an asynchronous method. So we have the bulkhead here, and then we have asynchronous here. Now this method has two parameters, value and waiting task queue. Now value here refers to the number of concurrent requests that can hit this particular component at a given time. And then the waiting task queue here refers to the number of queued requests that are waiting to hit the component. Again, the value here of 5 refers to the concurrent number of requests that we want to hit this component at a given time. And then the waiting task queue refers to the number of requests that we want to queue to hit this request. So when a request comes in and then there is, say, 4 requests, it adds up to make it 5 concurrent requests to this particular component. The 6th request gets put in a queue. The 7th, 8th, all the way to 10 requests will be queued. Now, an extra request, say the 11th request that comes in, will cause an error, an exception to be thrown, and then this fallback can kick in. So with the bulkhead annotation here, we are saying 5 concurrent requests, and then 10 can be in a queue at any given time. Anything outside of that, an exception will be thrown, a bulkhead exception will be thrown, and then this particular fallback can kick in. Now this is for the thread pool isolation bulkhead pattern. The semaphore pattern is what we have here. For that one, you can use on a non-asynchronous method or a synchronous method. So we have the bulkhead and we are passing in a value of 5. So all we are saying for this particular bulkhead usage is that only 5 concurrent requests can hit this method at any given time. That's all. So this is how you can use the bulkhead to prevent failure cascading all over your microservices. You use the bulkhead to limit the number of concurrent requests and the number of requests that are queued to hit the given component at any given point in time.
Okay, so we've briefly taken a tour of the various annotation available to you from the MicroProfile fault tolerance API to help you develop robust, resilient, and scalable cloud-native enterprise Java applications. We looked at Fallback, Timeout, Retry, CircuitBreaker, Asynchronous, and Bulkhead. Now, these annotations, apart from what we've looked at in the IDE, also have a way you can customize them. You can set their parameters using the config API. You can set their parameters at the global level, at the class level, and even at the method level. So for instance, with the fallback annotation, we can set such that for every fallback annotation we use in our class, a certain method name should be used, or with the timeout annotation, we can set and say for every timeout, the default timeout should be, say, 500 milliseconds. There's that fine-grained way you can set the parameters using the config API. We've not touched that in this particular brief course, but there is a detailed guide available from the Payara website where you can download together with the source code for your convenience and then really go through the guide and be able to apply the fault tolerance API construct in your application. This course served to whet your appetite to using the fault tolerance API in your applications. So go onto the Payara website. There are a number of other guides there based on other guides for MicroProfile there as well. Get to the Payara website, download the fault tolerance API guide, and then you can see how to incorporate this very powerful API into your microservices so that you can also develop reliable, resilient, scalable, cloud-native enterprise Java applications.